Okay, what we got here is a single line diagram showing the MSB, the generator, and our utility feed. Our utility feed is coming through this medium voltage 12 kV to 480 volt transformer. That comes down here into these two main breakers. We have two 3000 amp trip, 3000 amp frame breakers. They both feed along this bus bar right here. Now, this is where things get interesting. We have two breakers, one the MBB and the one is called the MIB. And you'll notice this KMB. This is the Kirk key situation that I'm talking about. So essentially, we have a circuit, the SKRU circuit, that essentially holds the key and allows us to close both of these breakers at the same time. Now you might be asking, why would we need a Kirk key system on this? And the reason why is we have a UPS. This UPS here is a paralleling system, 800 kW each. Each one of these UPSs takes in 480 volt AC and outputs 480 volt AC. But in between 480 volt AC, we got this DC link. So essentially what we have is a rectifier and an inverter. The rectifier is to charge up the battery system, and the batteries thereby, when we lose utility feed back into the DC link and continue the UPS outputting 480 volt AC. This 480 volt AC comes into these UOB breakers right here. There's two of them at 1200 amps each, and they both feed into the MIB. Yeah? This is our main input breaker. The main MBB, this is our main bypass breaker. So if we need to do work on these UPSs right here, then we can isolate them from the system, but keep feeding this bus bar down here, which feeds all of our main servers, and our panel 1, which is our EPMS circuit. One of the things that we want to do is to be able to close both of these breakers at the same time, because if we open them at the same time, essentially we lose our main bus breaker and the MIB breaker. If we open them both at the same time, we lose power to our critical bus, and we do not want to lose that, because essentially that's where all our servers are being fed from. So if we look at this right here, we have power coming in from our utility, coming in here, goes across, and it feeds in through our MBB downstream to our critical bus. Now that's when we're in maintenance bypass. Normally the way this works is we send power out through FCB 1 and 2 for our paralleling system, and it comes back from the UPS on our UOBs. This 480 volt system, when it converts from AC to DC, is not going to be in the same frequency as our utility with the output of our UPS system. So sometimes we have to put these UPSs into what is known as maintenance bypass. So I'm about to show you that right here. Okay, right here I'm approaching the UPSs. I'm putting them into control, and I'm basically doing a startup. Right now I've just closed the input breakers. As you can see, both FCB 1 and 2 are closed. Both UPSs are energized. I'm doing a startup wizard, and I'm starting up from maintenance bypass, meaning that both UPSs were de-energized. Next step is to close the battery breakers. So I come over to the battery breakers, open up the door, and I close all 4 battery breakers on each UPS. And this is for both UPSs since they're a paralleling system. Next, I have to move this to static bypass. As you can see, the bypass light is come on. I come over to the UOB breakers. I can close the UOB breakers, so I pump them up, charging up the spring on each one. And then I close both of them. Normally, if the UPS is not in maintenance bypass, then I do not have key release. So if we go over here right now, the next step is to close the MIB breaker, And to close the MIB breaker, I need the second Kirk key. So I come over and I see the second Kirk key. I press the release push button and I remove this key. So now I have access to two Kirk keys. One is already in because the MBB breaker is closed. Second breaker, the MIB, needs to be closed so that I can maintain power to the critical bus, as we talked about before. Pumped it up. I'm going to close the breaker. Both MIB, MBB are closed. Now I can open up the MBB, take the key out, put it back into key release. This is part of the SKRU circuit. Once I put the key in and now it's captured, the UPSs are online and we get all three green lights, and I've successfully started up both UPSs. Startup sequence successful.